Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Level 32. Determine the moment of inertia of the radius and the radius of gyration of the shaded area shown with respect to the x-axis. So here is the given figure. And let's consider vertical strip on this problem. Then let's extend it. And the thickness is dx. The height, we have two heights. This is y2. And for the lower end of the shaded strip, y1. Then the distance of the strip from the y-axis is x. And therefore, for differential ix, we have two strips. One is higher, the other is lower. So differential ix is equal to 1/3 y2 cube dx minus 1/3 y1 cube dx. So 1/3 y sub 2 cube dx minus 1/3 y1 cube dx, or simply 1/3 quantity y2 cube minus y1 cube times differential x. y2 is k2 x to the 1/2. So differential ix is 1/3 quantity k2 x to the 1/2 cube minus k1 x squared quantity cube dx. Since k1 and k2 are constants, so let's just put them before the integral sign and rewrite in the following manner. So k2 cube over 3 integral of quantity from 0 to a x to the 3 halves dx minus k1 cube over 3 integral 0 to a of x to the 6 dx. So the integral here is x to the 5 halves over 5 halves, or this is 2/5 of k2 cube over 3 times 2/5 of x to the 5 halves from 0 to a minus k1 cube over 3 times x to the 7 over 7 from 0 to a. Substituting values, and ix is 2k2 cube over 15 a to the 5 halves minus k1 cube over 21 a to the 7. Then let's evaluate k1 and k2. When x is a, y is b. So b equals k2 a to the 1/2. So k2 is b over a to the 1/2. While for this curve here, b, y1 is b when x is a. So b equals k1 a to the 2. So k1 is b over a squared. And substitute into this equation and simplify. So ix equals 2 b over a to the 1/2 cube over 15, then a to the 5 halves minus b over a squared cube over 21 a to the 7. If we simplify this is 2 over 15 ab cube, then minus 1 over 21 ab cube. Using the calculator, simplifying, ix is 3 over 35 ab cube. Now for the radius of gyration, we need the area because kx is square root of ix over area. And the area is simply area of the strip, integral of the area of the strip, upper y, y2 minus y1, that's the height, times the thickness dx. So area integral from 0 to a of y2 minus y1 dx. Y2 is equal to k2, which is ba to the 1/2, then x to the 1/2 dx minus y1, which is k1 b over a square x square dx. So integrating, this is 2/3 b over a to the 1/2 x to the 3 halves from 0 to a minus b over a square x cubed over 3, or b over 3a square x cubed from 0 to a. So take note that this is a to the 1/2, a to the 3 halves over a to the 1/2, that's a, 2/3 ab, the first term, and this is b over 3a square a cubed. So area is 2/3 ab minus 1/3 ab, and that is 1/3 ab. Substitute here, so polar radius of gyration, or the radius of gyration with respect to the x-axis, is square root of ix 3 over 35 ab cubed over area ab over 3. So this is square root of 9 over 35 b square. So it is 3 over square root of 35b, or approximately that is 0.5071b. Level 33, determine the moment of inertia and the radius of gyration of the shaded area shown with respect to the y-axis. So this is in continuation to level 32, but this time we want to derive the moment of inertia with respect to the y-axis as well as the radius of gyration with respect to that axis of this shaded area. So again, we consider vertical strip for our solution. Extend, thickness is dx. The height of the strip is y2 minus y1 as shown in the figure. And the distance of the strip from the y-axis is x. So that differential iy is distance squared times differential area. So x squared differential iy is x squared, then quantity y2 minus y1 times thickness dx. That's the differential area, y2 minus y1 dx. So y2 is k2 x to the 1/2. Differential ix is x squared, quantity k2 x to the 1/2, then minus k1 x squared dx. So at this point here, x is a, y is b. So let's evaluate k2 and k1. So b equals k2 a to the 1/2. So that means k2 is b over a to the 1/2. Then b equals k1 a square. So that means k1 is b over a square. So that iy is integral b over a to the 1/2 integral of x to the 5 halves from 0 to a. Variable of integration is x, so limits would be 0 to a, minus b over a square k1 integral of x squared times x squared, so x to the 4th dx. This is x to the 7 halves over 7 halves, or 2 over 7 b over a to the 1/2, then 2 over 7 x to the 7 halves from 0 to a, minus b over a square x to the 5th over 5 from 0 to a. Substituting, iy equals 2 over 7 a cube b. If we simplify this, then minus 1/5 of a cube b. Simplifying, iy is equal to 3 over 35 a cube b. Then for ky, it is square root of iy over area. Then the area is simply up y2 minus y1 times dx. So area equals integral from 0 to a y2 minus y1 dx. This is differential area. Y2 is equal to k2b over a to the 1/2 x to the 1/2 minus b over a square x square 10 dx. So area equals b to the b over a to the 1/2, then x to the 3/2 over 3/2. Reciprocal of 3/2 is 2/3. That's why you have here minus b over a square x cube over 3. So it is now this one. That's the over 3 x cube. So this is 2/3 AB. This is 1/3 AB. If we simplify, then minus b over 3a square a cube. So simplifying, that's 2/3 AB minus 1/3 AB. So the area is 1/3 AB. Then ky is square root of 3 over 35 a cube b over 1/3 AB. So this is 3 over square root of 35 a, or approximately 0.5071 of a. Level 34, determine the rectangular and polar radii of gyration of the shaded area about the axis shown. So here is the given figure. Then we use the results from level 4. We develop a formula for moment of inertia with respect to the x-axis and with respect to the y-axis for this general curve. Anyway, we have this curve here, then minus this hollow part or empty part, and the degree is 3. So Ix, if you can recall from part 2 and level 4 problem or problems, Ix is bh cube over 3 quantity 3n plus 1. That's the formulas. By the way, this is 2 comma 2 because when x is 2, 2 cube over 4 is 2 also. While here, this point here, when x is 1, y is 1/4. So that's 1 comma 1/4. So Ix is bh cube over 3 quantity 3n plus 1. If you can recall the formula we developed or derived from level 4. And Iy is b cube h over 3 plus n. B cube h over quantity 3 plus n, where n is the degree of the curve for this guide. But if you want to evaluate the moment of inertia with respect to the x and the y-axis, then you may have a vertical strip here, and that's the suggested way so that you can master evaluating moment of inertia of regions for any situation. So I'll just use the derived formula so that they will not be useless in the applications. But remember, these formulas were developed by integration. So we can actually evaluate this by integration also. So as an alternate way in your free time, I want you to derive or determine the moment of inertia with respect to the x-axis and the y-axis so that you can compute the polar radii of gyration of the shaded area about the x-axis and the y-axis. So for Ix, it is moment of inertia of this big region minus this small region here. So B is 2 for the big region, H is also 2. Then for the small region, B is 1 and H is 1/4, and the degree is 3. So area, by the way, is BH over n plus 1 in general, also derived in general from centroids of areas or regions, or from distributed forces, center of gravity. From that topic there, you may want to review it also if you have not mastered that topic up to this time. So Ix is 2 cube over 3 quantity 3 times 3 plus 1. So this is 16, 10, 30, 16 over 30, or or 8 over 15. Then minus 1 times 1/4 for this part here, quantity cube over 3, quantity 3 times 3 plus 1. So you just simplify using the calculator. So Ix is 341 over 640. Then the area is 2 times 2 over 3 times 1 minus 1 times 1/4 over 3 plus 1. The area is 15 over 16. Then Kx is square root of Ix over area. So Kx is square root of 341 over 640 over 15 over 16, and it is equal to 0.7539. Then for Iy, it is 2 cube times 2 over 3 plus 3 using this formula minus 1 cube times 1/4 over 3 plus 3. So Iy is equal to 21 over 8. Then the area is the same, 15 over 16. So therefore Ky is square root of 21 over 8 over 15 over 16. So 21 over 8 over 15 over 16, using the calculator, it is equal to square root of 70 over 5, or approximately 1.673. So KO is square root of IO over area, where IO is simply Ix plus Iy. So IO is Ix plus Iy, and it is equal to 341 over 640 plus 21 over 8. So IO equals 2021 over 640. The area is still the same, 15 over 16. So KO equals square root of 2021 over 640 over 15 over 16. So the polar radius of gyration with respect to O is 1.835. The other way is the relationship among this radii of gyration. Kx square plus ky square equals ko square, or ko square equals kx square plus ky square. Remember, because IO is area ko square, Ix is area kx square, Iy is area ky square. So the area as a common factor will be cancelled, so that this will be the relationship. So KO is equal to square root of 0.7539 square plus 1.673 square, or square root of 70 over 5 quantity square, and it will give us the same result of 1.835. So that's it.